Hey, good morning, Caitlin. Hey, we'll jump into it. We'll give just a couple minutes for everybody to get in because I'm sure they may have the same question. So give us a couple minutes to let everybody get in here, and then I'll answer number 10. All right, let's do a quick visual audio check. If you can hear me and see me, give me a thumbs up in the chat box or say something in the chat box in lines to that. All right, very good. So, Caitlin said she has a question about number 10 on the homework. So, number 10 right here is tangent theta. So for 9 through 10, we were just finding the value of the trig function. Okay, so find the value of the trig function. So when I'm looking at this right here, again, tangent, SOHCAHTOA. I know it's blurry. It'll clear up here in just a second. So we have opposite over adjacent. Okay, opposite over adjacent. So we don't have this third side, so we need to go find it. So we do that by doing a squared plus b squared equals c squared. And we got 6 squared plus b squared equals 22 squared. That's 36 plus b squared equals 484. We subtract 36 off of that and get b squared is equal to 448. Okay? We take the square root of both sides. And obviously we know, because we know our square roots, we know that the square root of 448 is not a perfect square root. So I'm going to come right here. B is equal to the square root of 448. But here's what we do know, is that this right here can be simplified. So we just need to simplify this down. So what perfect square root will go into that? Did anybody find a big one that goes into it? Okay, so it looks like that would be 64 and 7. 64 times 7 is 448. So then that'd be 8 radical 7. All right. Now, so that's 8 radical 7 there. So then from there, it's just tangent is opposite over adjacent. So 6 over 8 radical 7, which would be equal to 3 over 4 radical 7. And that's not what the answer key says, huh? Okay, so sorry about that. So 3 over 4 radical 7 is what we got there. Sorry, it took me a second to see what it was. And the issue with this, guys, is you cannot have a radical in the denominator. So you'd have to multiply top and bottom times the radical. That would take us to 3 radical 7 over radical. The way this looks is like this: 4 times radical 7 times radical 7. Radical 7 times radical 7 is just 7. You all remember that, right? Or radical 49, which is 7. And then 7 times 4 is 28. And that would be our answer. Does that make sense, Caitlin? I think, Abby, you had the same question. Is that making sense there? Can you all hear me? Oh, sorry. I didn't. All right. Oh, sorry. I wasn't scrolled up in the chat, and I was just sitting there. I was like, man, nothing's happening. Okay. Caitlin, are you good on that? Sorry, I didn't see your response on that. Caitlin, are you good on 10 now? Do you see that? Okay, that's that. And then Abby, you said 21. Okay, so 21, this is where we have to solve each triangle. All right. So Abby, tell me what did you do first here? What did you do first, Abby? What'd you go and find? Okay, cool. Any other questions from this homework, guys? I know that this was a pretty hefty one, but not too terrible. Just to remind you guys, these first 4 problems, it said find all 6 trig values of each function. So I meant to mark these little ones out, but make sure for number 1, 2, 3, and 4, you have all 6 trig functions. So just like we did on the notes for those 4, but the rest are you're just finding the single one. Okay? That's that. Make sure you have that. Any other questions on the homework? Any other questions at all on the homework? All right, give me a thumbs up if you're good and you're ready to go to the notes. Give me a thumbs up if you're good, you're ready to go to the notes. If you have a question, just shoot it in the chat box about the homework. Maddie's good, Dom's good, Abby's good, Caitlin's good. All right, assuming everyone is good, we now go to lesson 7.2 notes. All right, so here we go. Lesson 7.2 notes is all about angles of depression and elevation. Angles of depression and elevation. Angles of depression and elevation. Hey, and I just saw where Christina just emailed me her stuff. Make sure it is due today. What time did I say? 4 o'clock, I think. So make sure you get your work in. Those of you that submit it, submit it. Those of you that drop it off at school, hope you drop it off by the school sometime. All right. Make sure you get that to the school by the day if you haven't already. So angles of depression and elevation. All right. This is what we're discussing today. So the angle of elevation, okay, is an angle between a horizontal and a line of sight where the angle is above the horizontal line. Okay, so an angle of elevation is an angle between a horizontal line and a line of sight at which you see where the angle is above it. Okay, so this angle right here is what we call the angle of elevation. Okay, we have a horizontal line and we have the sight. It's looking up at the air balloon. The angle that is formed from the horizontal line and the line of sight and the line of sight would be what we know as the angle of elevation. The angle of depression is an angle between a horizontal, and I guess I should say horizontal line up here, horizontal line, and a line of sight where the angle is below the horizontal line. So, where something is looking down, okay, so we got a horizontal right here, and the line of sight looking down, that angle with the horizontal, and that would be known as what we know as the angle of depression. Okay? So, the two horizontal lines in any given situation, these two horizontal lines right here, okay, and we could these could almost be like imaginary lines or whatever. these two horizontal lines here would be parallel to each other. I have no clue how to spell parallel. Parallel to each other, and the angle of elevation and depression are congruent. Now, we won't see much of this. It's just a couple things to notice. Notice that if this is a 38-degree angle, that the angle of depression will also be a 38-degree angle. Okay, I feel like that was a little bit dark there, so I just wanted to try to help that shadow out a little bit. All right, so the two horizontal lines, they're parallel, okay, and the angle of elevation and the angle of depression are congruent. Angles that do this are congruent angles, and angles that do this are called what? Does anybody remember this from geometry or algebra or middle school math? What would these angles right here be called? What would these two angles right here be called? I'm really just seeing what you all know. Do you all know that? If you don't know, just say, hey, we don't know. Or I don't know. Okay, I'm going to assume you all maybe don't know. But maybe once you see it, you'll remember. Alternate interior angles. Do you all remember that? Alternate interior. There's interior angles. There's alternate interior angles. There's corresponding angles. Didn't know if you all remember that or not. Yeah, almost, Abby. Inside interior. But notice here, these are going to be, they are inside. They're interior angles, but they're alternate interior angles. Now, in algebra, again, did y'all study that in algebra? I really don't know when y'all study here. I taught it in algebra. When I taught algebra 1, I taught this in algebra 1. Was that in algebra 1 or was that like in middle school math? Or geometry? Okay, cool. All right, in geometry and pre-algebra. So you learn you begin it in pre-algebra. You talk about it in geometry. So we got middle school pre-algebra. You learn those, right? And then in geometry, you might have hit on them a little bit. And this is where all of that prior knowledge kind of comes in. So if you draw a vertical line, right here or right here, what do we have forming, guys? We have a what? Right triangle. Okay? Now, looking at this first example right here. So let's just kind of get this down. Let's identify what angles what and like kind of what it associates with. Okay. So what would angle 1 be? Somebody type it into the chat box. What kind of angle would this be? We have horizontal. We have 2 horizontal lines, and it's below the horizontal line. So what kind of angle would that be? An angle of depression or an angle of elevation? Angle of depression. Very good. So angle 1 is an angle of depression, and it's at the mountain. So we'll just say kind of like mountain here or something. Okay. So angle 1 up here by the mountains looking down. Okay. What about angle 2? What would angle 2 be? Depression or elevation? It's above the horizontal line, so it would be what? Elevation. Very good, Abby. Abby gets to get in the treasure box today for answering all these questions. So, and that would be the hiker. That would be at the hiker, right? Looking up. And then right here, it goes a little bit different, but notice he looks down. We have 2 horizontal line, guys. And guys, that's going to be the key here is horizontal lines, okay? When you make those go vertical, it'll get you all twisted. Your key is that you keep everything on a horizontal basis, okay? So when he's looking down, it's below the horizontal line. So that would be a depression angle. And that would be the hiker looking down. Okay? And then angle 4 down here, it's above the horizontal line, so it would be an angle of elevation. And that would be the house down there. Okay? Everybody kind of following this. Give me a thumbs up if you're with me. Good, Abby. Good, Maddie. Good, Christina. Good, Lucy. Good, Kristen. Okay, so let's go to the backside. To your absolute favorite word problems. All right, so here we go. Brian's kite is flying above a field at 65, or excuse me, Brian's kite is flying above a field at the end of a 65-meter string. The angle of elevation to the kite measures 70 degrees. How high is the kite above Brian's head? Okay, so we got a kite flying above a field, and it's at the end of a 65-meter string. The angle of elevation to the kite measures 70 degrees. How high is the kite above Brian's head? So, guys, those of you that absolutely love drawing, this is going to be your. This is probably going to be one of your better activities here. Okay, so you have to draw this scene. All right, I always want pictures. So draw a picture here of Brian Okay, so I have Brian here, and I'm a phenomenal artist. I don't need you to tell me any otherwise. So we got Brian. We got Brian right here, and Brian is flying a kite. Okay, flying this kite up in the air. Nice, beautiful kite with a cross on it. Jam with the lamb. So there we go. Now we need to list some things we know about this. Okay, we know the angle of elevation. Okay, it gives us the angle of elevation is 70 degrees. All right. Now think about our two horizontals here. Now, of course, most of the time I wouldn't draw these. I'm going to draw it for the first one. But we kind of have a horizontal right here, and we kind of have a horizontal right here. All right. Most of the time I'm not going to draw those, but just trying to get you the gist of what's happening here. All right. So Brian flying a kite. The kite is at the end of a 65-meter string. So that tells me if it's at the end of a 65-meter string, that this string length right here is 65 meters. Okay. Now it says the angle of elevation to the kite measures 70 degrees. How high is the kite above Brian's head? So 70 degrees. Would my angle of elevation, I want you to write this in. I'm going to give you two options. Is it right here at number 1 or is it right here at 2? Where is the angle of elevation in this scenario? Type in the chat box 1 or 2. Which one do you think it is? Is it 1 or 2? Maddie says 1. Christina says 1. All right. Not very active today. But yes, it would be 1. 1 is our angle of elevation. So we know, so I'm just going to kind of cross those out. So 1 right here is 70 degrees. That angle right there is 70 degrees. Now notice here, from here, we could form a perfect right triangle. Okay? And what we're wanting to know, okay, is how high is the kite above Brian's head. All right. So really here, does it say how far he's, okay, no, it doesn't. So it doesn't talk about how tall Brian is here, so we don't have to factor in anything within that. So we just need to basically figure out what's the height here. Okay? What's the height? So really this question could say, how high is the kite above, because Brian's head would be a little bit different. How high is the kite above the ground? I probably should have changed that. Sorry. How high is the kite above the ground? Now, what are we going to use to determine x? What are we going to do to determine the height of the ground? The height the kite is off the ground. What are we going to do to determine that? We're going to use trigonometry. Okay? So, we know we have SOHCAHTOA. 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 All right? So, yeah, theta, sine. All right? So, notice what we have here. I'm wanting to find this. So I need to find that right there. So that, what is that compared to our theta angle? It's x, and then which is opposite, over hypotenuse. Okay? So here, opposite over hypotenuse would be sine. So I'm going to say sine of 70 degrees is equal to x over 65. Okay? So then from here, this just takes us back to yesterday. Multiply both sides by 65. And I get x is equal to, and then calculator, 65 sine. What mode should we be in? What mode should we be in? Degree. Very good, Maddie. Degree. Good, Christina. So just to give you an example, the top one is in radians. And it will give you an answer, guys, that might not seem that far off. But the bottom one here is the one in degrees. All right. So I got, and we're just going to round everything to the nearest tenth. So 61.1 meters. 61 on your homework, round everything to the nearest tenth as well. 61.1 meters. And with stuff like this, I would always just write a little sentence to go with this. The kite is 61.1 meters above the ground. All right. Give me a thumbs up on that. You guys good? Makes sense? Thank you, Kristen. All right, let's jump to number 2. From an airplane at an altitude of 1,200 meters, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. Okay? So, let's make our beautiful airplane. So we got this airplane. Okay? Got this airplane flying in. And and we can make it, I fly southwest, so we'll say southwest here. So we got southwest flying in here, and it says that it is 1,200 meters, the angle of depression is. So, the angle of depression to a building on the ground. So, really, guys, what I would do here is I would really look at where are my horizontal. So I have a horizontal here, and I have a horizontal with the ground. Okay? And on the ground is a building. So let's put this building right here. All right? Here's this building. All right? And here's what it's saying. The angle of depression from here to there is, what is it, 28 degrees. So, tell me this. Should I draw my triangle on the left side or the right side? Okay. How should I draw my triangle? The left side or the right side? If that's making sense to you. Do you all see what I'm saying there? Okay. So I think this is a good, really good teaching point right here. So let's say I draw it on this side. And I make my triangle down here. Okay. You with me there? Okay. So Abby then says right because you want to see the building, not the ground. So look at this right here. Here's what I want to ask you guys on this question right here. Is this right here, is this angle right here, we'll just call it angle theta, is that an angle of depression? Answer that, yes or no. Is that an angle of depression? And the answer to that is no, it's not. That's not an angle of depression, okay? Because your angle of depression is always below this line, okay? So this technically would not be an angle of depression, so we would not want to draw this on the left, but what we'd want to draw it is right here on the right and make it look like this right here. Again, we have our two horizontal lines, okay? So this over here would be bad. Don't draw it like that. So we know this angle of depression, which is below the line, is 28 degrees, and it's flying at a 1,200 meter altitude. So we know that this distance over here is 1,200. From there to there is 1,200. So we could potentially, I could even write it right here if that would kind of help you see it a little bit better. 1,200. So this angle is 1,200. What we're trying to figure out right here is the hypotenuse. Okay? We're trying to figure out the hypotenuse. So, what are we going to use here to find this x? Which trig function? Based on this angle right here, look at what we have there, look at what we have here. What are we going to use? We don't ever want to go hypotenuse because that's a reciprocal trig function and that can get a little confusing in your calculator. So what should we do? Use what here? What trig function? Sine, cosine, tangent? If you had to use a reciprocal function, you could, but I'd try to avoid them if you can. So what we're going to use here should be sine. Yeah, very good, Christina. So opposite over hypotenuse. So sine of 28 degrees is equal to opposite over hypotenuse. So we multiply x on both sides here, multiply by x on that side, okay? That cancels. I'm left with x sine or times sine of 28 degrees is equal to 1,200. Then divide both sides by sine of 28 degrees. X is then equal to what? 1,200 divided by sine of 28 degrees. I got 2,556.1 meters. Now, you always want to check and say, hey, does that sound right? Is that sounding right there? Well, if that's 1200, we know that this is the longest part of this triangle. So I think it's reasonable to say that that could be 2556.1. All right. So I'd write a little sentence. The plane is 2,560 or 56.1 meters from the building. And we're assuming here that it's talking about the base of the building. Don't make your homework hard saying, well, what is it talking about? Is it talking about this or is it talking about that? Just assume that it's, going to be talking about something pretty simple. You guys cool there? Give me a thumbs up if that makes sense to you. So now we're basically just applying trigonometry. Where can trigonometry be used in the real world? All right, going on to number 3. From a point on the ground, 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53. Okay, Lucy. So, Lucy, you know where the hypotenuse is at all times. You good on the hypotenuse, I assume. It's always going to be the longest one, okay? But to determine where the opposite is, you have to look at whatever angle you have, okay? So this is the angle I have right now, 28 degrees. So your opposite, the opposite side will always be whatever this is directly opposite from, okay? Notice how this side is opposite of that, but this side is right on it. So this side is opposite, this side is adjacent. Going back up here, you're good on the hypotenuse, so then it's just a 50-50 on which one's the opposite and which one's the adjacent. But notice how x is the opposite because it's opposite of this side. That would be adjacent. Again, if I can draw this triangle any way I want. I can make a bunch of different triangles here. It can really change. Now, the thing about this, or actually, let me do this. Let me draw a triangle like here. Let me draw the same triangle, just so make sure you're getting this. Let me draw the same triangle. Now, if my angle that I'm dealing with here is like this angle, theta right here, okay? We know this is hypotenuse, and then the hypotenuse is always going to be easy. It's always the longest one. But whatever side is opposite, it's on the directly opposite of that, that will be the opposite side, and the other one just has to be the adjacent. But now look at this. If theta was right here, hypotenuse is still stay the same, but notice how opposite now goes over here. Opposite's over here because it's the opposite side of it, and then adjacent would be here. That make more sense, Lucy? Okay. So, hope you're good there. So, looking back at the flagpole question, so we have a flagpole, and from a point on the ground 12 feet from the base of the flagpole, the angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? So we have this distance from here out here to this flagpole. That's 12 feet. Okay? oh, sorry, you can't see that. So we have this distance from a point on the ground all the way to the base of a flagpole, which is 12 feet, okay? And then we have this flagpole right here. All right. And we could, we could make a flag be flying here. Actually, here would be our stars, right? America. Okay. I kind of butchered this flag just a little bit. I'm trying to show, some wind in there. Do you see that, Abby? Do you see that artist coming out of me? So, what we want to know is, what is X? How tall is this flagpole? And it says it has an angle of elevation to the top of the pole at 53 degrees. So again, guys, here's my two horizontal lines. You got to look at everything in that whole two horizontal lines mindset. So right here, my angle of elevation right here is 53 degrees. All right. So I want to find this. So what trig function am I going to use based on this right here? What trig function am I going to use? Tangent. Good, Kristen. So I'm going to use tangent. So tangent of 53 degrees. Now, what is tangent? What is, don't forget, SOHCAHTOA. SOHCAHTOA, okay? It's opposite. Notice this right here, Lucy. That X is opposite of their angle, and then this right here would be adjacent. So tangent of 53 degrees is equal to X over 12. We multiply both sides by 12. Cancels, and X is then therefore equal to 12 tangent of 53 degrees. And I'm getting 15.9. 15.9 feet. The flagpole has a height of 15.9 feet. The flagpole has a height of 15.9 feet. What little marks? Christina, you're killing me. Just remember that one mark is feet, 2 marks is inches. 1 mark is feet, 2 marks is inches. All right, look at number 4 then. I guess we're all good. From a plane flying due east at 265 meters above sea level, the angles of depression of 2 ships sailing due east measures 35 and 25 degrees. How far apart are the ships? Okay, so we got our Southwest airplane. Don't forget, never eat. I don't know how you all were taught this. Never eat soggy worms. So that's the way I was taught it in elementary school. That's the way it's always been. So we got an airplane. And this airplane is flying due east. Okay, so it's flying east, which is this way, right? He's flying east, and he is 265 miles or 265 meters above the sea level. So down here we have some water down here. And of course that would be our other horizontal line, right guys? The sea level, okay? And it says we have two ships down there. So we have our first ship and we have another ship. All right? Waffles would make more sense. Now, it's flying due east, 265 miles above the sea level. Now, here's the issue that I see a lot of kids make. They want to do this right here. They want to say the airplane is 265 meters above the ground. And here's what that does. It almost forces them. It almost forces them when you draw it like that to do this right here. And to do this right here. And you want to say that this right here is your degrees. But that's not true. Okay? That's not true at all, guys. That right there, these angles right here and right there are not angles of depression of that line right there. So be careful about where you draw the height. I know it's easy, it's a height of 265, but really where you want to draw this would be, right here and right here. Okay? And then from there, we know it makes an angle of depression here, and it makes an angle of depression there. So, let's work this first triangle first. All right, let's work this one right here first, guys. So, notice it didn't tell us which one was, 35 and which one was 25, but we should know that, all right? The thing right here, okay, the larger degree here, so like think about a triangle. If it was this angle right here would be smaller than this angle. This angle's getting bigger, right? So this angle right here would be our 35 degree one. Okay? So this angle from there to there would be our 35 degree. And then we know that this right here would be 265. So, again, if you need to redraw that over here, you could do that. So we got a 35 degree and 265. Okay? And what we're trying to figure out is its distance. We need to find this distance here, okay? And we need to find the distance here, then obviously subtract the two. All right, so what would we use for this right here? If I'm trying to find x right here, because the distance from this plane to that plane, and I guess you could go about it a couple different ways here. You could go about it at looking at that distance to that distance and then subtracting. Or you could just look at this distance and that distance and then subtract. You want to find that right there. So the total distance here minus the total distance here would give you the distance that boats are apart. So a couple different ways you can work these problems. So Maddie says tangent. So that would be opposite over adjacent. So tangent of 35 degrees is equal to 265 over x. We multiply both sides by x, and we would have x is equal to, that cancels there, 265 divided by, once I divide that side, tangent of 35 degrees. So I'm skipping a step there. I'm multiplying x on both sides, but instead of rewriting everything, I just go ahead. I know I'm going to divide both sides. 265 divided by tangent 35 degrees is equal to 378.5. 378.5. So this distance right here, from here to here, is 378.5. All right. Now let's work the other one. Let's work this triangle now to determine its distance. Okay, so I'm going to come over here, make another triangle. Sorry. X, we know that's 265, but this time it's just from here to there, and that's a 25-degree angle. So the whole one was 35 because it's obviously the bigger angle. 25 would be that one. 25 degrees. And then I use the same thing, which would be tangent 25 equals 265 over x. And then x is equal to 265 over tangent 25. And that's x equals 568.3. So from here to here is 568.3. So if the total distance from the airplane to this one is 563 and the total distance from the airplane to this one's 378, then we just say this minus that to get our difference between the two boats right here. So 568.3 minus 378.5. That's a 189.8. And we're dealing with meters here. So I would just say down here the ships are 189.8 meters apart. On your homework, I want you writing sentences. Just write one sentence about what's happening. Open your eyes, Christina. Thumbs up. Give me a thumbs up. Give me a response to that. Give me a thumbs up. Let me know. Does that make sense? Good Abby, good Maddie, good Lucy, good Kristen. There has to be more than you 4. It says there's 10 watching. Anybody else? Dom? You all good? All right, here's what I'm going to give you 5 minutes. I want 5 minutes. Knock this out. I'm going to come back on here. Good, Caitlin. I'm going to come on back here at 3:36. 336. I want you to do this on your own. I'm going to complete it. You do yours on your own, and then we'll check, see how we feel. Okay? I'm going to mute my mic for a minute, and then I'll jump back on here at 336. Do problem 5. You guys good? You got it? Give me a thumbs up if you're finished. Okay. Make sure your answer agrees with mine. All right, let's see who's honest here. Who got it right? Type it in the chat box. I got it right. This is why we can't have anything nice, Caitlin. Christina. All right. Very good. Looks like you're all good there. Pretty simple. Hey, your homework's the back. I just gave you 5 problems. You just swiped up 10. Okay. Gave you 5 problems on the back. Knock those out. And I'll meet you. I won't see you guys again until Monday. Unless you all wanted to, are you guys interested in Zooming tomorrow afternoon? I would only be available like tomorrow afternoon about 3 o'clock. If that would work for you all. 3:15. Will that work? Are y'all interested in Zooming, or y'all got stuff you got to do? Just let me know. So Christina says Zoom. I got to have somebody besides Christina. Good, Kristen. You're 5 minutes late to the party. I'm just joking, Kristen. All right, sounds good. Just keep your mom at home this time, Caitlin. So I'll do a Zoom tomorrow. I'll send you some details out. We'll do like 3:15 tomorrow. Meet for a little bit. Tomorrow's a really nice day, so we don't have to meet for too long, just to say hey, catch up with everybody, make sure everyone's doing good. Make sure you do 7.2 homework. Make sure you turn your stuff in to me as soon as possible from Chapter 6. If you guys don't have any other questions, you're free to be dismissed. Thanks so much for being here. Thanks so much for your commitment to my class, commitment to your education. Everyone know I have no seniors in here, so it's so valuable you guys are here taking this stuff in. Missing these lectures, and I know that some people have to work and doing other things, and to be honest, I don't mind when you all watch them, but just keep in mind, being here is very, very good for you, especially because you will see me again next year. So that's all I have. Thanks so much. Have a good day. You all, I'll be on here for shortly if you have any questions of me. I'm going to mute my mic, but I'll be on here for a couple minutes just to answer any questions anybody may have. Thanks.